world and beyond. Space, in partnership with the European Space Agency.
Over 1.5 million kilometers away from Earth, for the last 2 years, the Herschel Space Telescope has been observing the universe. It detects radiation emitted by the coldest bodies in the cosmos, which can only be seen using infrared light. The results are these images, extraordinary to common mortals, but a treasure trove of information to astronomers.
The history goes back 30 years, and at the time Herschel was called FIRST, the Far Infrared and Submillimeter Space Telescope. And the idea was to open up the last remaining part of the spectrum between the infrared and the radio, which you cannot see from the ground because of the atmosphere.
Joran Pilbrat has dedicated much of his working life to this project, one of the most ambitious ever launched by ESA, the European Space Agency. Astrochemists from all over the world gathered in Toledo, Spain, for a symposium on the information gathered by the Herschel Space Telescope about the chemistry of bodies in far space. This city has been a meeting place for scientists since the 12th century. Here, in 2000, ESA renamed the first project Herschel in honor of the scientist who had discovered infrared rays 200 years earlier. Let's take an astronomer's view of the M31 galaxy in the Andromeda constellation, over 2 million light-years away.
The aim is to get the complete understanding of the sources that we observe. You get a completely different story in the different wavelengths. You see different things. In the optical image, basically you see light from stars. So you see the stars which are there in the galaxy now. When you go into the infrared, you see emission from dark, big clouds of gas and dust in Andromeda. And in fact, this is the parts of the galaxy where stars will form in the future. In the X-rays, you see stars which lived and died. So the three pictures are very complementary.
Cardiff in Wales successfully mixes old and new, both in architecture and in science. Cardiff University was asked by ESA to design and construct SPEAR, one of the 3 detection and analysis instruments mounted on Herschel.
Like this, you have dials. Herschel carries 3 scientific instruments on board. The hi-fi instrument is like a very sensitive radio receiver. It tunes in to the vibrations of atoms and molecules out in space and can measure them. And then the 2 other instruments called PAX and SPIRE operate in different wavelength ranges. So PAX covers the shorter wavelength range and SPIRE the longer wavelength range. And they both have the 2 kinds of instruments that astronomers like to use. Cameras to take pictures, and to take pictures at different wavelengths, in different colors if you like, and spectrometers to break the light up into its different wavelengths and then study in detail the signatures of different atoms and molecules using a technique called spectroscopy.
The engineers designed a complex cooling system based on helium for the 3 instruments. They're enclosed in a sort of thermos flask. The temperature inside is always around minus 273 degrees Celsius.
If we didn't do that, then the instrument itself would produce so much radiation, so much infrared light, that we wouldn't be able to see the faint astronomical objects that we want to look at. So this is a big nuisance. It's a lot of work to get down to these low temperatures and to keep the entire instrument cold.
The Space Telescope looks like a 7-meter long, 4-meter wide tube and weighs 3.3 tons. It's protected by a heat shield, which incorporates a solar panel. The telescope's main mirror is a technical marvel in itself. 3.5 meters in diameter, it's the largest ever sent into space. The polish is 100% perfect, and it's extremely light because it's incredibly thin. It's been tested to the limits, however.
The instrument has some moving parts, and those moving parts are very, very delicate, and they need to be able to survive the experience of a launch, which produces a great deal of heavy vibration, and things can fall apart if they're not very well built.
On the 14th of May 2009, the Ariane 5 was launched from Kourou in French Guiana. On board were two of the most ambitious scientific projects ever attempted by ESA. The Planck satellite, designed to measure fossil radiation emitted during the formation of our universe, and the Herschel Space Telescope, which records the coldest galactic objects in the cosmos. Herschel was the first to begin its journey to a precise point in the solar system, the Lagrange number 2. A zone 1.5 million kilometers from Earth, where the gravitational pull of the Earth and the Sun cancel each other out. That's where Herschel operates. The telescope can therefore continually point its instruments towards the observational field, with the Sun continually behind it.
Every 6 weeks approximately, we just give a little tiny push from Herschel's rockets just to put it back into exactly the right orbit so it doesn't wander away. If we left Herschel on its own, then it would move slowly away. It might crash into the moon, it might escape into orbit round the Sun.
An ancient fortress dominates ESAC, the European Space Astronomy Centre, just outside Madrid in Spain. Here, they sort through observation requests from astronomers all over the world. Working closely with ESOC, ESA's operations centre in Darmstadt in Germany, which is in charge of Herschel's movements, ESAC receives scientific data and translates it into graphics which can be used by astronomers, and then makes it available over the internet. The ESA scientific archives are also stored here. All the information gathered from all ESA's space missions, including Herschel.
In the time that we've had so far, just a year and a half, we have got terabytes of data. In fact, tens of terabytes of data. It is a fantastic amount, which is being stored in the archives here.
The improvement in the quality of the information that Herschel gathers compared to other space telescopes using infrared, like NASA's Spitzer, has opened up new horizons for astronomy and stellar chemistry.
Herschel has exceeded all expectations. It has produced the most fabulous scientific results. It's producing some images of a quality that we just couldn't believe. And such a complicated machine with so many parts that could go wrong. Everything is working. Everything is working almost perfectly, which is just unbelievable out there in space. We are going to learn so many things, and people are going to be working with Herschel data maybe for 20 years after the mission actually ends.
The Herschel Space Telescope has enough helium for the cooling system to continue operations until 2014. It will continue sending observation data and receiving instructions thanks to the most modern satellite tracking station in the world, the Cerebros, which is operated by ESA from Sierra de Gredos in Spain. Lionel Hernandez is the manager there.
With that antenna, we can work with the satellite up to 900 million kilometers away. So Herschel, only 1.8 million kilometers away, is quite close for us. The antenna is 35 meters across. We have 3 very powerful amplifiers, one of 400 watts, one of 2 kilowatts, and one of 20 kilowatts. For Herschel, the 2 kilowatt amplifier is enough. It's 2 million times more powerful than a mobile phone.
There's a very similar antenna in New Norcia in Australia, which takes over every 12 hours when Herschel and ESA's other scientific satellites are out of sight from Spain. In only a year and a half, the advances made in terms of stellar astronomy have been enormous.
We can see star formation going on 10 billion years ago in the early universe. And we can also observe in our own galaxy the chemistry in these clouds from which stars form. We are starting to make the connection between the physics and chemistry of the clouds to the nebula in which a star forms, to the disk around the forming star because it's rotating, and the chemistry in the disk and the chemistry of our planet. Herschel has more than 30 years of history, and it's through the imagination of people who have been working on Herschel for all this time that we have been able to make this possible. I'm a newcomer. I only worked on Herschel for 20 years.